Hello dear students, welcome to my YouTube channel. One second. I need to check the audibility and visibility. Am I audible and visible? Hmm? Am I audible and visible? So, in the previous class, we had studied about electric potential energy and electric potential, and I guess one more topic that was closest approach, right? Or conservation of mechanical energy or conservation of linear momentum. These things we actually completed in morning, the 8 o'clock session. Okay, so we will continue the session with the topic as electrical potential. Okay, so let us continue the session. Okay, I guess in the previous class we had discussed up to this particular numerical. Okay, how to find electrical potential. This thing we had done now the previous class. So from today onwards, we will be discussing some numericals, some PYQs. Okay. Look now, we will do a numerical, and the numerical is like check whether the electric field is zero or electric field is not equals to zero, and electrical potential is zero or electrical potential is not equals to zero at center. At center. Okay, this is my numerical, and my figure would be like this is my figure. Yeah, square figure. Okay, so here if my charge particle plus q is at this corner, here minus q is at this corner, plus q is at this corner, and minus q is at this corner. If the length of this square is L, suppose it is L, and L. Okay, now this is the center of it. Okay, look, if we are measuring, firstly we will measure the electric field. What will happen now? Look, just because of the positive charge, electric field will be in this direction. Let us know it is E. Okay. Now, due to this negative charge, it has its electric field E. It will be same now. Why? Because distance is same from the center. In the same way, this electric field will what? Attract it. E. And this electric field will what? Repel it. Like this. So you can see now. Now look, you can see now. In this way, we have 2E. In this way, we have 2E. 2 and the angle between them is 90 degrees. So how to get net? How to get net effect? It will be 2e cos 90 by 2. I will write 2 to the 4. It is 4e cos 90 by 2 is cos 45 degree. I will write 4e cos 45 is 1 by root 2. I will write it 4 root 2 divided by 2 e. So my E net at the center will be equals to 2 under root 2 e. Okay, so here electric field intensity at the center is 0. Hello beta, electric field intensity at the center is 0. Now we will check for the electrical potential. For electrical potential, due to this charge, my electrical potential will be equals to K, Q. If distance is X, let us suppose it will be X. Okay. Due to this one, it will be K, but minus Q due to divided by X. Due to this one, no? Similarly, due to this one and this one. So now this one, it will be K, Q by X. Due to this one, it will be K minus Q divided by X. Now add all of them, V net. It will be equals to K Q by X plus K Q by X minus K Q by X minus K Q by X. You can see from this particular, now look, this will get cancelled out. So we will get V is 0. Yes, V is 0. Okay, so here V is 0, but E is not 0. Electric field is not 0, but V is 0. You will find after now, we will do some numericals, you will find that even if E is 0, V will be constant. Easy numerical though. Good numerical, but easy numerical. Okay, let us do some more numericals. Good numericals. In the class, we had to complete, I guess, around 20-30 numericals. Okay, be in the class. Look, one more numerical. And numerical is like, this is my numerical, look. It is up to infinite. X-axis. This is my x-axis up to infinite. This is my origin, 0, 0. Okay. Now here, I have charged particle Q and distance is R. Here, I have charged particle Q, distance is 2R. Here, I have charged particle Q, distance is how much? 4R. Here, I have charged particle Q, distance is how much? 8R. And so on. Now we have to find the net potential due to these forces, these charges at this origin. So what will be as per V1? So V1 would be, sir, K, Q divided by R. This one, it would be, sir, V2 is equals to K, Q by 2R. This one, V3 is equals to K, Q by 4R. This one, V4 is equals to K, Q by 8R. Okay. Now what will be, and so on. What will be V net? Sir, I guess V net, I can get V net as a V1 plus V2 plus V3 plus V4 plus so on. Plus so on. Now place the values. V1 equals to KQ by R. V2 is also KQ by 2R plus V3 is KQ by 4R. V4 is KQ by 8R plus so on. Plus so on. Now look, I guess I can take KQ by R outside, now common. So I will write 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus so on. So if you can see this clearly, now it is infinite GP series. This one is infinite GP series. So the sum of infinite GP series is first term divided by 1 minus common ratio. What is first term, sir? It is 1. 1. What is common ratio? Common ratio simply indicates the ratio of two successive terms. So I will do 1 by 4 divided by 1 by 2. What is R? Sir, R is equals to 1 by 4 divided by 1 by 2. I guess answer is 1 by 2. Yes, it is 1 by 2 only. So I will get 1 divided by 1 by 2, which is equals to 2 only. So here I will write 2 only. So V net is equals to KQ by R. Now here I will write 2. So can I write it 2 KQ by R? I can write 2 KQ by R. Very easy now. So look, here you can see we have added two concepts. One is GP series. Second one is the superposition of your potential. Am I visible now? Let me see it. Hmm? My voice is okay. Now my voice is also no, audible and am I visible? Okay, now look, one more numerical, and numerical will be like similar, now the ditto one, but with different look. If we have something like this, it is up to infinite. Okay, here this is my center with 0 comma 0. You can see here, first charge is q, distance r. Second charge is minus q, distance is 2r. Third charge plus q, distance is 4r. Then it is q, it will be minus q, then it is 8r. Then 16 as usual. So what will be the V net? Sir, it will be V1. What is V1? So V1 is K Q by R. Then minus K Q by 2R. Then plus K Q by 4R. Then minus K Q by 8R plus so on up to infinite. So what I can do here, I will take K Q by R common. Then what I have 1 minus 1 by 2 plus 1 by 4 minus 1 by 8 plus so on. So look, it is an infinite GP series. So what will be sum of it? So sum will be first term 1 minus comma ratio R. First term is 1, whole 1 minus comma ratio, I can write 1 by 4 divided by minus 1 by 2, it will be minus 1 by 2. No? It's my comma ratio R. So I can write minus minus 1 by 2. So answer is 1 divided by 1 plus 1 by 2. It will be how much? I guess 2 by 3. 2 by 3 is my answer. So now I will write, sir, V net is equals to KQ by R multiplied by 2 by 3. Okay. So this is my V net at the center or at the origin. Done. I guess you don't have any confusion now, no? Very easy. Let us do some tough one now. Okay. Tough one. How to find it? Look now. Tough one now. Tough one. We have a square. We have a square. It is rectangle now. I will make automatic square. Square. Okay. Now look. Here we have charge plus q. Here charge plus q. Plus q. Plus q. Length is L. 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 L and L. So this is my point. This one is the point. Point number P. It is at central. No? Here, what is VP? Look now. Due to this charge, we will be having potential here. Yes, sir. So look, the distance will be L by 2. What is potential? V1, it will be K Q whole divided by L by 2. Now, due to this one, I will write V2, that is K Q divided by L by 2. Now, due to this one, now I have to just connect these two. L by 2. I will write here L square plus L square by 4 under root. So I can write it 5. No, look here. I will write it as a 4L square plus L square by 4. No, 4 under root. So I will write 5 by 4 L square root. So it will be equals to L by 2 under root 5. Okay. So this length is equal to how much? It is under root 5 by 2 times L. Okay. So what is potential due to this one? Sir, V3 KQ whole divided by under root 5 by 2 times L. Now due to this one, I guess it is same, no? V4 equals to KQ whole divided by under root 5 by 2 times L. Okay, now what will be V net? I guess V net is equals to V1 plus V2 plus V3 plus V4. V1 equals to KQ divided by L by 2. V2 is KQ divided by L by 2. V3 is KQ whole divided by under root 5 L by 2. V4 is KQ whole divided by under root 5 L by 2. Okay, look now. So I can write it equal to 2KQ by L plus 2KQ by L plus 2KQ by under root 5 times L plus 2 times KQ whole divided by under root 5 times L. So I will write 2 to the 2 to 4, it is 4KQ by L. Here I will write 4KQ by 5 root L. Okay. So what is V net now? So I can V net equals to, I guess I can take what? It is L here now. Okay. I will take 4KQ divided by L common. Then I have 1 plus 1 by root 5. This is my answer. Hi beta. This one is my answer. Easy? Is this easy? Okay. But please watch the morning class now. That is important one. Okay. Now, next one. Look, we have a question. And the question is like, my charges are like this. Here, I have charge particle minus Q. Here, I have charge particle plus Q. Okay. This is midpoint. Distance is A and A. I will go R distance upwards, the equatorial point here. So at this particular point, I need to find potential, electric potential. How I can get it? Look. Here, first of all, one potential will be according to this minus Q. Look, I can write, look, this is A square plus R square root according to Pythagoras theorem. No? So I guess this one will be also how much? Under root A square plus R square. Now here potential will be this one and this one also. So according to this one, the potential will be V1. It is Q divided by R. What is R? It is under root of A square plus R square. This will give potential V2 and V2 equals to K plus Q divided by under root of A square plus R square. What will be the V net? I guess V net equals to V1 plus V2. So I can write minus KQ whole divided by under root of A square plus R square plus KQ whole divided by under root of A square plus R square. Both cancel out. So my V net is equals to 0. But we know that, sir, E net is not equals to 0. We had done it, no? We had done it in previous classes. Okay, no? Kp by R cube. I guess I'm going stuck now. Once again, look, I will just check my network. That is good. It is good. Then why is lagging? Okay. Now one more numerical. Different numerical now, okay? We'll just do a different numerical. And the numerical like at a point P. It is at a point P now. At a point P. Electric field is given as 100 Newton per coulomb. And potential is 50 volt. At a particular point, now it is 50 volt. Then find the distance. Find the distance of point from charge and find the magnitude of charge. So at a particular point, electric potential is 50 and electric field is 100 due to the charge particle, right? We need to find out the distance between the charge particle and the point P. If my charge particle is here, point P is here, so we need to find the distance and also the magnitude of this charge. Sir, how we can get it? Look, how? Look, so what we will write now? Look, we will write, sir, E is given to be 100. Good. V is 50. Okay. It is given now. Two things are given to us. Okay, sir. What is E? What is E, beta? I guess it is KQ by R square. Is it 100? Yes, sir. What is V? Is it KQ by R only? Is it 50? Divide them. Look, KQ cancel, KQ cancel. 1R cancel. 50, 52 is 100. So I am getting 1 by R is equals to 2, I guess. I get R came out to be 1 by 2, that is 0.5. 0.5. Now I will take this formula, this one. Sir, KQ by R is 50. Okay. K is 9, 10 to power 9. Q is Q. What is R? R is 0.5. Okay, 0.5 equals to 50. Okay. So I can write here, sir, Q came out to be, it is 50 into 0.5 whole divided by 9 into 10 to power 9. Done? Just cancel out 0.55, 25. It is 25 by 9, 10 to power minus 9. So 9 on the 9, 9 to the 18, 27, no, to the 2.7 something, 10 to power minus 9 coulomb. This is my answer. This is what you have to learn. This is how you need to manipulate your answers. Sometimes my video lags, no? So don't pay attention to it. Just we have the material in front of us now. We have to just focus on the material in the class, okay? One more numerical. And you had done this numerical couple of times now in back classes also. If we have a rod like structure like this, with length L. This length is L, okay? This one is point P. This length is also what? L. L. Then find potential at point P due to this charged rod. If the charged rod is having charge plus Q. Look now, we had studied only one thing, that is potential due to point charge. So look, we are assuming the rod is made up of small tiny particles. So we can apply the formula QQ by R square. Yes. So if we are encountered by this formula, now this kind of problem, what we can do? We will go across distance and we will cut a dx element. Dx element. Okay. Dx element. If charge on whole is Q, so the charge on this particular will be how much? dq. Done. So what is V? Sir, V is KQ. What is Q? Sir, dq by distance. It is X. Sir, X. It is dV now. What is dq now? Look, we have L length. In L length, my charge is Q. So in 1 unit, my charge will be Q by L. In we have how many? In dx, my charge will be how much? Q divided by L, then dx. So in dq now, I can write like this. Yes, sir. So K, what is dq? Sir, dq is Q by L dx whole divided by x. So I can dv, I will write it equals to k q divided by lx dx. I can write like this now. So I will integrate it. Okay. Look, this point is L from this point and this point is 2L. Look now. This one is 2L. So my integration will be from L to 2L. The integration of dv will be v only. K is constant, q is constant, L is constant. Integrate from L to 2L only 1 by x dx. Okay. Look, integration of 1 by x is ln of x. So I will write v equals to kq by L. Then it is ln of x. Okay. Then upper limit is 2L, lower limit is L. So I will write here. Okay. So v came out to be kq by L. Upper limit ln of 2L minus lower limit of ln of L. V equals to kq by L. I can write ln of 2L divided by L. Okay. Log of a minus b, log a minus log b. LL cancel out. LL cancel out. So V equals to KQ by L ln of 2. This is my answer. This one is my answer. Easy or tough? Huh? Easy or tough? No, this is how you need to manipulate your answers. Okay, very easy one. Okay, next numerical, it is somehow we need to apply some vectors here also. Okay, the coordinate geometry things. Look now, we have a coordinate sort of thing now. Look, x-axis, y-axis. Origin, at this origin, I have charged 1 microcoulomb. Okay, A point. We have a point, coordinates are 0, 2, comma 0. B point 0, comma 2. C point is under root 2, comma under root 2. Okay. So what is potential at A, potential at B, potential at C? I will write formula. Potential would be KQ by length. Length is 2. I will KQ by X. Let us suppose X, right? It is X. This formula we have to apply. Look, first formula is 2, comma 0. So X is 2, Y is 0. I guess this point is here. It is A point, 2, comma 0. So this length is how much? 2. B would be here, no? This is my B. Okay, this is my B. And coordinates are 0, comma 2. It is 2 only. Now C is here somehow. C is here somehow, no? It is my C. Coordinates are under root 2, comma under root 2. That simply indicates, look, this side is root 2 and this side is root 2. So what will be hypotenuse? Sir, it will be root 2 square plus root 2 square, like this. So I will just simplify it now. It will be 2, 2 to the 4. I guess my answer is 2 here. What is potential at here? No, sir, K, Q. Q is how much? 1 microcoulomb divided by distance 2. Here also, it is K, 1 microcoulomb divided by 2. Here, it is K, 1 microcoulomb divided by 2. So I guess it is K. Okay, I guess I need to know potential at each point is the same now. So can I write here? One second. Can I write here that, sir, potential at A is equals to potential at B equals to potential at C, no? Equals to K. K is 9, 10 to power 9. 1 microcoulomb divided by 2. 2 on the 2, 2 4 the 8, 2 5 the 10. It is 4.5, 10 to power 3 volt. This is my answer. This is how we have to manipulate the numericals to get our answer, no? Okay. Next numerical. No, not numerical. So do you know that what is potential, no? Basically, what is electric potential, no? So electric potential means if we have to bring a charged particle from infinite to a particular point, we have applied some external force. Due to that force, some displacement happens. So we are saying that the work done in bringing a positive unit charge from infinite to that particular point, this work done gets stored or gets changed into the electric potential. Hello, beta ji. Okay, so simply you will saying that, sir, electric potential means work done per unit charge. So look now, I will write, sir, work done, potential at any point P equals to work done by external agent or force to bring a particle from infinite to a point P divided by that moving charge particle. That moving charge particle. It is external. If we have to write the same thing into an electrical thing, we know that work done by external equals to minus times work done by electrical, because we had proved it now by the work energy theorem. Okay, so I can write here, it will become minus work done by electric. Work done by electric from infinite to point P divided by Q, that moving charge. Or let us suppose we have 2 points. we don't have infinite, we have 2 points. So how we can write? I will write electric potential at final, electric potential at initial equals to work done by external force from initial to final divided by Q. I can write like this. So can I write now my work done by external force is equals to Q times V final minus V initial. So one formula is here, work done is equals to Q delta. This one. Okay. So we get a formula W equals to Q delta V. So on this basic thing now we will do a numerical. Okay. Look, look better. Very good numerical and easy one also. And my numerical is like this one is J numerical. Okay. We have a point P where electric potential is given 10 volt. We have a point Q where potential is given minus 4 volt. These things are given to us. Calculate work done. Calculate work done in moving. Calculate work done in moving 100 electrons from point P to Q. From point P to Q. Okay. So we know that if we have to find out work done. So what is the formula for work done, sir? Work done equals to Q delta. Work done equals to charge which we are moving. It would be potential at a final minus potential at initial. What is final? We have to move it from P to Q. So Q is final, P is initial. Okay. So what is formula for VF? Look now. So V final would be equals to K Q by R. We can write like this now. No, it is given to us now. Why we are just applying this thing? No, it is given to us. So I can write it W equals to Q. What is Q? So we don't know. Here we have 100 electrons. We know one formula Q equals to NE. Okay, sir. Q is Q. What is N? N is equals to 100 electrons. What is E? E means charge minus 1.6 10 to power minus 19. Okay, it is minus 1.6 19 10 to power minus 17 charge. So I can write here 1.6 is 10 to power minus 17. It's minus, no? V final means VQ. VQ is minus 4. Minus what is VP? VP means 10. It is minus 10. So W came out to be minus 1.6 10 to power minus 17. It will be minus 14. Minus minus cancel. 14 into 1.6 is, and my, okay, 14 into 1.6 is, it give me 22.4. 10 to power minus 7. Joule answer. This is my answer. Famous people. Hmm? I'm waiting for network to get good now. Hello, beta. Welcome back. I guess I am visible and audible to all of you, right? So let's continue the class. Okay. So this was the numerical that we had just now discussed now. How to find the work done. Okay. 1 second. Okay. So how to find the work done? We had the formula. Work done. We can just Q into change in potential delta V. That is one numerical from AIPMT also. We have AIPMT also, and the numerical is like, look, we have a, okay. So it is something like, look here, we have a distance like this now. So here it is point A with charge minus Q, or here is one more point. Here one point, here one more point. Okay. So if this is point number A, this is point number B, point number C, point number D. Look now. So this distance is L. This one is also L. So here I'm having a semicircle. This semicircle. Now I have here positive charge plus Q. Plus Q. I need to transfer the positive charge plus Q from B to D. How to get my work done? Look now. Work done is equals to, am I audible? Once more second, I need to check it out. My network to do with it.